in the latest version and other. But essentially, you just go to Set, you go to Social Engineering Attacks, you go to the Arduino-based attack vectors, and you select what attack vector you want to do. And it has some of the X10 stuff that we've been doing with jamming, which I'll talk a little bit about. And then my favorite one is deploying a binary via the Teensy attack. And what's cool about this is you can actually drop a binary onto the system and have it convert back and run a binary. So, if my demo works, we should see some magic typing happening here. No hands. Kevin's whistling. And so what's happening here is it's deploying a payload onto the system using a hexadecimal representation. And so what we're going to leverage is PowerShell to reconvert our hexadecimal representation of our binary back to a binary again. And what's cool with this one is I leverage a tool called shellcode exec, which, if you're not familiar with shellcode exec, it's just an executable where you can give it a second argument parameter that's alphanumeric shellcode, and it shoots an interpreter straight into memory. So it never touches disk. And so in this case, you're going to see it convert here in a second. We're going to do our conversion. Come on. Here it goes. It's doing its conversion. This took a long time to code, by the way. My wife hated me on this one. Sorry, Erin. She's actually here. Oops. And so we execute, and lo and behold, I didn't have my listener up. Oops. Well, it would have dropped a shell. All right, hang on one second. Let me hook it up real quick. So right now it's generating the alphanumeric shellcode. It's going to stage everything into hexadecimal representation of it. It's going to create the PD file through Arduino, and this is what it actually looks like over here. So you can see the Arduino stuff right here. So this is all the code that it's doing. And then we're going to do this one more time. Sorry. That's what happens when you forget to do stuff.
I remember when we were testing this, and I was testing this on this, what was it, an Acer 1? Yeah, and the timing on this thing was like crazy. And so Dave and I, had to spend like a few days with the timing on it because it was just like funky.
Yeah. On slower computers, we ran into the issue that it was typing out way too fast for the actual computer to handle. And so, and usually I have that problem on whenever I'm typing, so can't handle me. But, in this specific case, we ended up working it out and getting the timing down right and everything. But, essentially what you can do with this, and what's cool is we did a modification to the Teensy device, which I don't have one on me right now. But Josh ended up soldering a SD card onto the Teensy device, and now you can do native SD storage on the Teensy device. But why that's important is when you plug it in, it doesn't recognize as a storage device because the Teensy actually natively reads in the SD card, so you can store as large of a binary as you want to on it, and then copy it off. So you're not restricted with the characters that you would have leveraging the Teensy device, because the Teensy device only has like 128K and 64K based on the model you get. And so if we go back to our attacker machine here, there's the interpreter shell.